Okay, the first question. Displacement S of an object moving at constant acceleration A within time t is given by the equation S equals KAT squared. So they are asking for the dimensions of K. So in order to find the dimensions, let's first take the equation, that is S equals KAT squared. So we know since this is an equation, dimensions at the both sides should be equal. So I can write this equation as dimensions of S, that is the displacement, equals dimensions of KAT squared. Then dimensions of S, that is capital L. Dimensions of K, that is what we need to find. Then dimensions of acceleration is L t minus 2. Then dimensions of time squared, that should be t squared. Then t minus t squared cancels off. Then this L and this L cancels off. Then dimensions of K is equal to 1. Meaning that K does not have any dimensions. So it does not have any dimensions. So K is equal to 1. It is dimensionless, so the answer should be the fifth one for the first question. Now moving on to the second question. Velocity of a sound in a gas at pressure P and density rho is given by V equals Kp divided by rho root. For this as well, they are asking for the dimensions of K. So the equation we given is V equals Kp divided by rho root. So for this as well, we just have to get the dimensions for the equation. So the dimensions at both sides of the equal sign should be equal. Okay, it is easier if we just take the square, the equation. So V square is equal to K P over rho. Then I am going to take the dimensions of each term. So dimensions of velocity is Lt minus 1. Lt minus 1 is the dimensions of velocity, and that gets squared. And this is equal to K P over rho dimensions. Then L squared T minus 2 equals dimensions of K. Then this is dimensions of density. Density is mass divided by volume. So mass divided by volume means ml minus 3. So for the pressure, if you don't understand how to get the dimensions of pressure, pressure is force divided by area. Force is ml t minus 2. Area is L squared, length squared. So if you simplify this becomes ml minus 1 t minus 2. Then you just have to substitute the dimensions of pressure here. So it is ml minus 1 t minus 2. Okay. Then this t minus 2 cancels off. L minus 3, when it goes up to the numerator, it becomes L squared. And that L squared and this L squared gets cancelled off. This capital L and capital M cancels off. For this one as well, dimensions of K is equal to 1. Meaning K is dimensionless. So the answer for this one, for the second question, is 5. For fifth option is the answer for the second question. Third question. Correct sentences about distance are. So the distance cannot be negative. Distance cannot be zero. Distance traveled does not decrease with time. Distance cannot be less than the displacement. So those are the four sentences we have given. They are asking for the correct sentences. Yeah. So if you think about distance and displacement, distance is the scalar. We mean it that distance only has a magnitude. So putting a negative sign there won't be useful. So distance, we only consider the magnitude of that. So distance is only a positive value. It cannot be negative. Yeah. So the A option is correct. Then they say that distance cannot be zero. Yeah, distance can be zero if the object is not moving. Let's say object is not moving at all. It's just remain at rest. So the distance for that object is zero. So B is wrong. Distance cannot be zero. Distance can be zero. It can take the value of zero. Then they say distance traveled does not decrease with time. Yeah. If the object is at rest, the distance, value of distance will remain at zero. And if object moves to here, distance increases. And if the object comes back, even the object comes back, distance it traveled increases. Because let's say this is the S1, this length is S2. Distance traveled is S1 plus S2. So the moved length is added into the distance. But here, the displacement, which is a vector, it can decrease. Because here the displacement is S1 minus S2, but the distance is S1 plus S2. So with time, distance can only increase, or it can remain constant. But the displacement could decrease if the object is coming back to the original position. So the distance traveled does not decrease with time. That one is correct. So C is correct. Then D, distance cannot be less than the displacement. Yes. Distance cannot be less than the displacement. Because distance only adds up, that length only adds up to the distance, but displacement always decreases if the object is coming back to the origin. So therefore always the distance is a higher value, or it can be equal to distance, but it cannot be less than the displacement. So that's the difference between distance and displacement. So D is also correct. So the correct answer should be fourth one for the third question. Okay, moving to the next question, fourth question. Two cars A and B moves towards the same direction, starting from the same place. So cars are starting from the same place, and they are named A and B, starting from the same place and moving to the same direction. Then they say the speed of car A is 50 kilometers per hour and the speed of car B is 60 kilometers per hour. If the car B starts moving after an hour of the movement of car A, time required for car B to pass car A in hours is. So they're asking for the time required for the car B to pass car A. So car A starts earlier. So let's say car A keeps moving. then keeps moving. After 1 hour, B also starts to move to the same direction, but it has a higher speed. So car B can pass A after a while. Let's say the passing point is here, is at here. Then the time elapsed for car A is simple t. Time taken by B to pass car A should be t minus 1, because car B starts 1 hour later. So car B only takes t minus 1 time in order to come here to the passing point, but car A takes a time t. Then we can say that the distance for both cars is the same. So we can make an equation. Distance by car A equals distance traveled by car B. Okay, so there's no acceleration here. This is only a constant velocity, so we can apply S equals ut. So distance traveled by car A should be ut, meaning here u is 50, time is t, equals distance traveled by B is 60, speed 60, then time is t minus 1. 60 means 10t minus 60, 0. Then 10t equals 60, t equals 6. So the unit showing kilometers per hour, so the time here should be 6 hours. So meaning that car B takes 6 hours in order to pass car A from the beginning, right? I mean, here car B moves for like 5 hours, here car A moves for 6 hours. Within 5 hours, car B, from its starting position, car B takes 5 hours to pass car A. So when that happens, car A has moved for 6 hours. Okay? Because car B starts moving after 1 hour. The next question, that also from linear motion, maximum height that an object reaches and time required for it to come back down if it is projected upwards with velocity 80 meters per second. So they are asking for the maximum height and time required for the total motion. The object is projected upwards at 80 meters per second. You know the gravitational acceleration, that is 10 meters per square second. When the object goes up and moves down. So they are asking for the maximum height that the object reaches. Simply you can apply this equation, u squared plus 2as. We know that the velocity at the top is 0. So we apply the equation from O, A, B, from O to A. This equation is applied from O to A. Final velocity is 0. Initial velocity 80. Square plus 2 times acceleration, that is, acceleration is downwards, 10 meters per square second is downwards. So since I'm applying the equation upwards, this value is minus 10. Then if the maximum height is capital H, you can say that displacement is capital H. Then 20h is equal to 80 squared, means this is 64. 2 zeros, then h is equal to 320 meters. So 320 meters is the maximum height that the object moves So I have to figure out the correct equation to be applied. Using that equation, you should be able to easily find the answer within a short period of time. So this is the proper equation to be applied. We applied this equation because they haven't mentioned anything about the time yet. So this equation does not have any term with time, and also the final velocity that is 0. So we can apply this equation and easily solve to get the answer. That's why we applied this one. Okay, then they're asking for the time. That time is the total time it took, that object took to move, to start, goes up and come back down. So for that, I'm going to apply this equation. Half AT squared. So this is applied from O to B. O to B means from here to here for the total motion. So when it goes up and comes back to O, the displacement is 0. Displacement is 0 because it is at the original position. U is 80 t plus half acceleration downwards. So I'm applying the equation upwards. So the acceleration is downwards, then this becomes minus 10. And this is t squared. The t cancels off, t squared cancels off. This becomes minus 5t. I can take it to the other side. Minus 5t equals 80. So t equals 16 seconds. So this is the time taken for the whole motion of the projected object. So the answer for that should be the maximum height is 320 meters and the total time taken is 16 seconds. So the answer should be fourth one for the fifth question. Sixth question. A swimmer jumps into a swimming pool from a platform at a height 12 meters. If the inclination of initial velocity 8 meters per second is 30 degrees, distance to his landing position from edge of the swimming pool is. Okay, so this is a question about projectiles. The swimmer jumps into a swimming pool from a platform. So let's say, so here's the platform. The height to the platform from the swimming pool is 12 meters. 12 meters. If the inclination of initial velocity 8 meters per second with horizontal. So this is 30 meters, 30 degrees, and the initial velocity is 8 meters per second. Then they are asking for the distance to his landing position. So he moves in this parabolic path on the projectile. Then he lands somewhere here. So they are asking this distance, so distance from here to here. Let's say like that distance is like simple x or something. Then simple x is what we need to find. Okay, first we need to find the time required for this whole motion, meaning that time required for the swimmer to move from here to here. For that, the easiest way is just to apply ut plus half at squared. So I'm applying this equation for the whole motion of the swimmer. So I'm applying it vertically upwards. When the swimmer moves from here to here, the vertical displacement of the swimmer, we are neglecting the horizontal displacement. the vertical displacement of the swimmer should be 12 meters, but since we are taking measurements from this point, it is 12 meters below. So S here should be minus 12. Then initial velocity, that is upwards 8. The component is sine 30. 8 sine 30 is the vertical component. T plus half. This here also minus 10 because acceleration is downwards, vertically downwards. Then this is t square. Then minus 12 equals 8 sine 30 means 40 minus 5t square. Then take this to the other side. 5t square minus 40 minus 12 equals 0. So by solving this equation, you can find the total time for the whole motion. So you have to get the factors of this equation. So let's say 5t square minus 40 minus 12 equals 0. 5t square minus, so 5 times 12 is 60. Easiest way is if it is 60, 10 times 6, right? So if you put minus 10t plus 6t minus 12, that is equal to 0. Take 5t out, t minus 2 plus 6, t minus 2 equals 0. Take t minus 2 out, then 5t plus 6 equals 0. t minus 2 equals 0, or 5t plus 6 equals 0. So here this term time becomes minus 6 over 5. It is not possible, the time cannot be a negative value. So here the value should be 2 seconds. So the total time required for the swimmer to move from here to here is 2 seconds. Okay, now we know that. So what we need is to find this x distance. So for that, I can apply the same equation horizontally. So the horizontal displacement is x here. Then horizontal initial component, velocity component should be 8 cos 30. 8 cos 30. This is 8 cos 30, right? Or sine 30, cos 30. That is a horizontal velocity component. 8 cos 30 times t. T we found t, right? Same time. That is 2. We found it. Plus, there's no acceleration horizontally. The acceleration is only vertical downwards, which is gravitational acceleration. This is 0 now. X equals 8 cos 30 means root 3 over 2 times 2. 2 cancels off. Then 8 root 3 meters. This is the horizontal displacement for the swimmer. So the answer here is first one, right? 8 root 3. That's the answer for the 6th question. Okay, the next question. An F-35 drops a bomb on a target when it is at a height h above the target. So you have to consider this instant. An F-35, that's a jet type, right? So let's say the jet is here. Then they say if the F-35 is flying horizontally at V, so that it is flying horizontally at V, distance to the landing position of the bomb and the target is, okay, the target is here, but the jet release the bomb right above the target. So what happens is, since the jet has a horizontal velocity, the initial velocity of the bomb also is going to be horizontally v. So the bomb takes a projectile motion. So it would land here, not on the target, right? So what they are asking is how much distance that bomb is misplaced. So let's say that distance is simple x. So first, for this one as well, we just have to apply S equals ut plus half at squared. I'm applying that downwards. So this is applied to the bomb, right? Then this height, they say that height is simple h. Yeah. So they are asking for value for simple x, I mean expression for simple x. First we need to find the time required for the bomb to move from here to here, meaning it is the same time from here to here. Okay, to downwards, displacement is h. Vertical component is 0 for the bomb, because the initially bomb only has a horizontal velocity component. It doesn't have a component downwards, velocity component downwards. So the downward velocity component there is 0 plus half gravitational acceleration is downwards. Okay. Then t squared. So h is equal to half gt squared. Then 2h over g, that is equal to t squared. Then the time is equal to 2h over g root. This is the time for the bomb to land on the ground. Then I can apply the same equation but horizontally. S equals ut, because there is no acceleration horizontally. That half a squared gets eliminated from the equation. So the horizontal displacement is x. Horizontal initial velocity, that is v. This does not change. This is a constant horizontally. So v and t. So x equals v. Instead of t, you can substitute this expression. 2h over g root. So this is the horizontal displacement of the bomb. That is v 2h over g. So the answer should be third one. Third one should be the answer for the 7th question. Okay, moving on to the 8th question. A ball is projected at 10 meters per second with inclination 30 degrees to downward direction. Ball hits at B and then at C after bouncing off. If collisions are assumed to be perfectly elastic, gap between B and C is. Okay. So this is the path of the ball. So they are asking the distance between B and C. The velocity component, the velocity is 10 meters per second. Okay, so first let's figure out the velocity, horizontal and vertical velocity components. So horizontally velocity should be 10 cos 30. 10 cos 30 means 10 times cos 30 is root 3 over 2. So this is 5 root 3 meters per second. This is the horizontal velocity component. Then vertical velocity component should be 10 sine 30. Sine 30 is half. So this should be 5 meters per second downwards. So we figure out that those are the horizontal and vertical velocity components of the initial velocity, 10 meters per second. Okay. Then they are asking for distance between B and C. Before that, we have to find the velocity that the object hits at B. So I'm not going to find the resultant velocity. Getting the velocity components is enough. Without any, the horizontal velocity does not change. Right? We know that it is not horizontal component is not accelerating. It's a constant velocity horizontally for any projectile. So the horizontal velocity component at B also should be 5 root 3 meters per second. Then we need to find the vertical velocity component at B. Okay, the time, we don't have to think about time. So I'm applying this equation v squared u squared 2as. This is from, let's say this is a point A. I'm applying this from A to B. So velocity at B, let's say that velocity is v. So v squared equals u squared. That is the vertical velocity component here. So that is 5 meters per second downwards. So 5 is squared plus 2 times, this becomes plus 10 because I'm applying the equation downwards. Gravitational acceleration also downwards. 10 times, this h is given, right? Yeah, that is given as 10 meters. This height is given as 10 meters, so you just have to substitute 10 here. So this is 200 and this is 25. So this should be 225 meters. So that is 15 squared. So V should be equal to 15 meters per second. So 15 meters per second is the velocity of that object. Vertical velocity here. Then they say that the collision with ground at B and C is perfectly elastic, meaning that there is no loss of kinetic energy. So once it bounces off, the magnitudes of the velocities cannot be changed. So the vertical component here, when bouncing off, also should be 15 meters per second. And the horizontal velocity component still does not change because it is perfectly elastic. 15 and to horizontal it's 5 root 3. So once you figure out these velocities 15 and 5 root 3, you can find the distance from B to C as usual. Okay, now I'm applying equations from B to C. First, you have to figure out the time for this projectile to move from B to C. For that, easiest way is apply this equation vertically upwards. So when the object moves from here to here, vertical displacement is 0. Vertical displacement is 0. It has a displacement horizontally, but vertical displacement is 0. Vertical velocity component 15 t plus half. Since I'm applying the equation upwards, gravitational acceleration is downwards. So this is minus 10 t squared. Then squared cancels off. Dividing the whole equation by simple t. 15 equals 5t. And t equals 3 seconds. So that is the time required for the object to move from B to C. Then again I apply the same equation from B to C to find the horizontal displacement. That is what they ask actually. So let's say that is the distance from B to C. I'm applying this equation horizontally. Velocity component is 5 root 3 times time we found as 3 plus this is just 0, right? Half AD squared. There's no acceleration horizontally. Acceleration horizontally is 0. So that is 0. Then you get 15 root 3. So this is the distance from B to C. I mean horizontal displacement from B to C. So it is 15 root 3. So how to figure out the value for 15 root 3? Is roughly 25.98 meters. So approximately the value from B to C, the distance from B to C should be 26 meters. If you round it off, you can round it off to 26 meters. That's the answer there. So the answer should be third one for the 8th question. Okay, next question, 9th question. A passenger moves 1 meters per second to opposite direction inside a train which is moving at 25 meters per second. So they are asking for the velocity of passenger relative to Earth. So there's this train. It has a velocity 25 meters per second. There's a passenger inside the train moving to the opposite side at 1 meters per second. So train, when they say speed of the train, they are saying the speed of train relative to Earth. Let's say train is capital T, right? Train is capital T. Relative to Earth, that is 25 meters per second. Then there's a passenger inside the train. So if they say that passenger inside the train has a velocity, so that is the speed of the passenger relative to the train, not the Earth. So speed of passenger relative to train, VPT, that is 1 meters per second to the opposite side. It is not relative to Earth, it is relative to train, because they say speed of passenger inside the train. Then they are asking the relative velocity of the passenger relative to Earth. So this velocity is relative to train, right? So by looking at this, we can say that relative to Earth, the passenger, if you are familiar with relative motion questions, you can say relative to Earth, passenger should have 24 meters per second speed to this side. But we can get the same answer using equation. So the equation is, so what we need is speed of passenger relative to Earth. So put a T here, that is train. VPT plus VTE. So VPT is 1 to this side. Speed of train relative to Earth is to this side. So if you simplify, these are two vectors. If you simplify that, I can flip the direction of 1 and make it a negative 1 plus 25. So the vectors are to the same side So you can simplify the numerical values. So this becomes 24 meters per second. So that's the relative velocity of the passenger. The velocity of the passenger relative to Earth. That is 24 meters per second. But relative to train is 1 meters per second. The opposite side. So you have to understand those concepts. So the answer should be first one for the 9th question. Okay, 10th question. A truck with mass 1200 kilogram moving at velocity 4 meters per second hits on a barrier and stops within 3 seconds. Average force acting on the truck is. Okay, the truck has a velocity 4 meters per second and its mass is 1200 kilograms. Then it collides on a wall and it stops within 3 seconds. So it takes 3 seconds for the impact. So they are asking the average force acting on the truck as it is with impact on the wall. Okay, so when truck is here, when it is in impact with the wall applies a force F on the truck, and truck applies a force on the wall. Those action-reaction forces. I'll apply this equation to truck. I'll apply that to this direction, right? So we know that for the truck, the force applied is to opposite direction. So this I can substitute as a minus F equals, it had the velocity 4 meters per second, then it stops. So the final velocity of the truck should be 0. Initial velocity of the truck should be 4. So it has a velocity 4, then it stops. So initial velocity is 4 meters per second, final velocity is 0. So U should be 4. So mass is 1200 times U is 4. So you just have divided by time now. Time for the impact is 3 seconds. 1204 divided by 3. This minus cancels off. Then we can get a value for capital F. 400 times 4, that is 1600 newtons. So this is the impulsive force acting on the truck as it collides with the wall. So that is 1600 newtons. So the answer is second one for the 10th question. 10th question. Strings are light and inextensible and the pulley is smooth. The tension of a string between 3 and 5 kilogram is. So there's this cable. Then there's a pulley which is smooth. A force of 100 Newton is applied on the string at this side. Then there's this 3 kilogram and there's this 5 kilogram. So they are asking tension between 3 and 5 kilogram. Let's mark it as capital T. Then there are weights acting on each mass. Here the weight should be 50 Newton. Here the weight should be 30 Newton. Then since the pulley is smooth, the tension at both sides should be 100 Newton. I mean at this this part of the string, right? So it should be just 100 Newton. 100 Newton upwards. So the total force acting on downwards on 3 and 5 kilogram is 80 Newton. Upwards there is 100 Newton. So it is obvious that this system should accelerate upwards. Let's say the acceleration is simple A. Okay. Then I am going to apply F equals ma. We need to find capital T, right? I'm going to apply equations to 5 kilogram and 3 kilogram separately. F equals ma. First, let's apply to 5 kilogram. Upwards, F equals na. Yeah, the forces acting on 5 kilogram, that is a tension, and 50 downwards. So since I'm applying it upwards, it should be T minus 50 equals 5 times A. So this is one equation. Then I'm applying equations to 3 kilogram. Upwards, F equals ma. Upwards there's 100 Newton. Then downwards there's 30 Newton and a tension. Minus 30 and minus t. Then mass is 3, acceleration is a. This is second equation. You can further simplify this equation. 70 minus t equals 3a. So this is the second equation. So 1 plus 2, you can add these two. Then get rid of t. Here we need to find t, but it is easier to find simple a first. So if we add these two, this becomes t minus 50 plus 70 minus t equals 5a plus 3a. That is 8a. This is this t cancels off. 70 minus 50, that is 20. So 20 divided by 8. 2 fours, 5 fours. So 5 divided by 2, that is going to be 2.5 meters per square second. That's the acceleration of the system upwards. Then you can simply substitute this acceleration in one of these equations. Let's take the first equation. So that is t minus 50 equals 5 times, simple a is 2.5. So 2.5 times 5 is around 12, not around, it is 12.5. T minus 50 equals 12.5, so t equals 50 plus 12.5. So that is going to be 62.5 newtons. So 62.5 newtons is the tension of the string between 3 kilogram and 5 kilogram. Next question, 12th question. A pipe with cross-sectional area 10 square meters is placed vertically. The water jet through the pipe holds a ball with cross-sectional area, with the same cross-sectional area, in air. The water jet suddenly stops after hitting the ball. So I have to assume that the speed water hits the ball is 1 meters per second. So let's say this is the pipe. Then there is a water jet emitting from the pipe. So that water jet can hold a ball in air in equilibrium. Meaning the force applied on the ball by the water jet is equal to the weight of the ball. Let's say the weight of the ball is mg. So here we can get an equation F equals mg. So this is the force applied by the water jet. This is the weight of the ball. So those two forces should be balanced. So the ball would be air. The thing is, we have to find this capital F. The cross-sectional area is given of the water jet as 10 square centimeters. This is the cross-sectional area of the water jet. So we can convert this into square meters just by multiplying 10 to the power minus 4. So this is going to be 10 to the power minus 3 square meters. This is the cross section of the water jet. Okay. So if you want to find the force applied by something like a water jet, you can use this equation. Then take m out. This is a v minus u. So m over t is the mass flow rate of water. So I'll put m dot there. This is v minus u. Since the water jet stops once it hits the ball, this should be v minus 0. So this mass flow rate, we can have an equation like AV rho. I'm not going to derive that equation. You should remember that. The mass flow rate from a water or any fluid flow, you can get that from like AV rho. A is the cross section, V is the speed of the water or the fluid flow, and rho is the density. So AV rho is equal to m dot. M dot times with this V, this is V. And this is A rho V square. So this is the A rho V square is the force applied by the water jet on the ball. Normally when we study the theories in unit source, we derive this equation, right? This is a force applied by a water jet. So here then we can write this AV rho, V square rho equals mg. Then you just have to substitute values for the equation and get an answer. So let's substitute values. Cross section is 10 to the minus 3 square meters. Velocity of the water jet is 1 meters per second, 1 squared. Since it is water, it is 1000, meaning 10 to the power 3. The mass of the ball, that they are asking for the mass of the ball. So gravitational acceleration G is 10. Okay, then 10 to the power minus 3, 10 to the power 3 cancels. So this is just divided by 10. So 1 over 10 kilogram. This is the mass of the ball. 1 over 10 kilogram means 100 grams, right? 1/10 of a kilogram, that is 100 grams. So the answer should be third one. Okay, on 13th question. An object with mass 2 kilogram, which is at rest. So 2 kilogram, initially it is at rest. Then it is applied a force capital F. The variation of the force is given by this, there's a graph, variation of that force with time is given as a graph. So FT graph. So here the value is 4, here the value is minus 2. So area of FT graph, we know that area of FT graph is equal to the change of momentum. So here the net area of FT is equal to change of momentum. Change of momentum is mv minus mu. So here you have to just find the net area of the graph. So net area of the graph, this time here is 4, then the time is 6. The area here should be 4 times 4. Area here is, this length is 2 seconds, then this height is 2. So it is 2 times 2. So 4 times 4 is 16. This is a negative area. So that is 4. 2 times 2, that is 4. This is 16. So 16 minus 4. This is equal to. So the mass of the ball is given as 2 kilogram. I am taking 2 kilogram out. They say that initial velocity is 0. So this is 0. So mass is 2. Then what they ask is the final velocity of the ball, which is simple v here. So 16 minus 4, that is 12, equals 2v. Then v equals 6 meters per second. V equals 6 meters per second. So the answer is third one. Okay, the next question. An object with mass m moves along x-axis and suddenly breaks into 2 identical parts. So there's an object, this is x and this is y. It is moving along x-axis. Let's say the mass of the object is m. Here the object is moving along the x-axis at velocity v. Then it breaks into 2 identical parts. So their masses of each part should be m over 2. Then they say that one of the part moves at v parallel to y-axis. So let's say after explosion, one of the part, that is m over 2, moves to the y-axis, parallel to the y-axis. So what they ask is the velocity of the other part, which also has a mass m over 2. Okay. So here, due to this explosion, we know that there cannot be any change of momentum for the system. So momentum before explosion and after explosion should be equal. Okay, since I don't know the exact directions of velocities, I am taking 2 velocity components for m over 2. Let's say this component has v2 and to x direction it is v. This is v1, this is v2. That is to the horizontal direction. I mean to x direction. Okay, all you have to do is just find these 2 velocity components. Then you can figure out the direction and the magnitude that this m over 2 moves. So first I'm going to apply linear momentum conservation to x direction. Okay. So for the system, right, I'm applying that to the system. To the system, this is before explosion, this is after explosion. So to x direction, momentum before explosion is mv. So that is equal to, for the system, after explosion. So only m over 2 has a velocity component to this direction. This does not have, right? This is to the y direction. So m over 2 times v2. So cancels of m, then v2 is equal to 2v. v2 is equal to 2v. So now we found v2. Then apply equations to y direction. To y direction, there's no initial momentum because momentum is to total momentum is initially is to x direction. There's no momentum to y direction. So the momentum here is 0 to y direction. Then this part has a momentum to y direction, that is m over 2 times v. Then this is other part m over 2. It is moving to opposite side, so this should be a minus here. M over 2 v1. Then m over 2 cancels off. v1 v equals 0. Then v1 is equal to v. So those, now we found the velocity components of the other part. This part, right? That is after explosion. So these are the components. So v2 is equal to 2v. v1 is equal to v. So these are the velocity components for this part of the object. So we can have an idea of the resultant force and the direction that the object moves from this diagram. So the resultant velocity should be to this direction. So this is the direction that this part moves. So the answers could be second one, third one, or fourth one. But this velocity is higher, this velocity is lower. So this angle should be less than 45 degrees. So the most suitable answer here should be second one, because this angle here should be less than 45 degrees. Right? You can figure that out by this diagram. This is the parallelogram or the vector rectangular for the velocity components of this part, m over 2. Yeah, so the answer should be second one for the 15th question.